それではいよいよ待ちに待ちましたファイスト博士にご登壇いただきます。皆様大きな拍手でお迎えください。パソコン向こうでねアテンドしてあれこっち
Professor Ida, all the community here in Japan, dear academic colleagues from university, all of you participating here, thank you very much. It's a big honor for me to speak here the first time in Tokyo, Japan. So I'm going to talk about the development of the passive houses, which mainly took place in Europe. And what you see here in the first slide, these are some examples. These are passive house social housing projects which has been built in Kassel and in Innsbruck. This is another project in Innsbruck of passive houses. All of these buildings are passive houses, and these are passive house office buildings. So there are already a lot of built passive houses which are being occupied at the place in Europe. You go to the next slide, please. So this is an information from the International Energy Agency. This is the agency which is responsible worldwide for the research in energy resources and for looking on the development about energy worldwide. So the International Energy Agency has always been in favor for the big industry model of energy, for coal, gas, natural gas and oil. And now we are publishing what they call the World Energy Outlook every year. And there was a surprising result in the last World Energy Outlook, because this is what the International Energy Agency now tells us about the global trends in energy supply. They are patently unsustainable, not only environmentally, also economically and socially. So this is what the International Energy Agency is talking about. But they also say there is still time to change the road we are on. And they say what is needed is nothing short of an energy revolution. So now let us have a look, how could that energy revolution look like? Next slide, please. And the next, please. The next. I would like to turn it myself, if that's possible. So what you see here, this is my dear friend and co-worker, Professor Bo Adamson. You have already heard of Professor Bo Adamson. He was also the host of Professor Kamata, who has been working together with him for quite a time at Lund University. So when I met Professor Adamson, that was in 1985, he just had an appointment with the Chinese government. So he was asked by the Chinese government to come to China and to give advice to the government. So why? Now in China, they have had energy supply problems all the time. So in southwest China, all the region south of the Yangtze River, in this part in China, heating was prohibited. So people were not allowed to heat their buildings. But the comfort in these buildings was very poor. So they suffered from very cold temperatures, which could be down to 10 degrees, 11 degrees during winter. So the government asked Professor Adamson to give some recommendation what they could do in order to improve the comfort in these buildings. And so he called these buildings passive houses because they didn't have an active heating system. So this is where the passive house comes from, the passive houses without heating system. So government asked him to improve the indoor climate in these buildings without adding a heating system. So, and this is what he did. So what he did is he recommended adding some more insulation. He recommended using double pane glazing. He recommended to tighten the buildings a little bit. So he came up with a concept for comfortable passive houses in southwest China. And then Bo Adamson came back to Sweden. And the first guy he met was me. And his mind was full of passive houses, passive houses, passive houses. What about building passive houses in Europe? That was his suggestion. He wants to build passive houses in Europe. And my thought was at that moment, now he's gone crazy. So I wasn't his opinion, so it was difficult for me to follow him. But we agreed, let's try. So we made a theoretical study of how it might be possible to build passive houses in Europe. And Professor Bo Adamson insisted that we not only do a theoretical study, but that we really built a demonstration building of a passive house in Europe. Now you have to know that in Europe, the climate is like North Japan. So it can be minus 15 degrees during the winter. So it's not so easy to build a passive house in Europe. So we had to use quite a lot of insulation. It had to be quite airtight. We needed new hand-manufactured windows. We put in a ventilation with heat recovery. So it was quite a big effort to realize these very first passive houses in Germany, in Darmstadt. So what you see here is a typical German row house. It's 4 units, each of them 3 stories, built by private investors. It's families who live in these buildings. This was built in 1991, and the architect of this development was Professor Bott. Professor Bott, another colleague from the architectural department, he later got a call from Stuttgart University, and he was teaching architectural arts at Stuttgart University, and that was the place where Miwa Mori was studying. So this is again some link to the Japanese development. So this was the house being built at the beginning of the 1990s. The next thing we did, this was thought to be a research project. So we wanted to know about what is it. Will it be possible to reduce the energy demand of buildings in the cold German winter by a significant, in a significant way? So we did that research. So we got some research money from a German state, the state of Hesse, to install monitoring equipment. So we measured all the temperatures, we measured humidity, we measured the consumption of energy. And this is one of the most important results of that measurement. What you see here is the years. This is 1991 to 1992. This is 92 to 93, 94, 95, 96. And these are all the all-year consumptions. So this is what is consumed in this building. Natural gas for heating. This is the red bar. Natural gas for heating. Natural gas for domestic hot water. And this is the electricity for running washing machines and other things, and the electricity, the yellow one, for running the ventilation systems. So what you see here, that the total consumption of energy is in the range of 20 kilowatt hours per square meter and year, and the heating is even less than 10 kilowatt hours per square meter and year. So now we compare that with the average German consumption. So the average German consumption, this is what you see here. This is what normally in an average German building is consumed for heating, 200 kilowatt hours. So this is down by more than a factor 10. So the whole research project was a big success. So these results have been published, and then we had a very important guest from the United States of America. This is a guy you might know he has been here at this university, I have been told, just a couple of months ago. His name is Amory Lovins. Amory Lovins came to visit us in this demonstration building, and after his visit, we were all sitting together to have some afternoon tea, and we were discussing the results, and I was discussing with Amory, and at some place, well, you know Amory, you have seen him, he's a very energetic guy, and when he told me, well, Wolfgang, you are completely wrong. So I was a little bit shocked. So now what's his opinion? Yeah, I'm completely wrong. So I was a little bit shrinking. So what does he not like on this development? Well, Wolfgang, this is not just a research project. This is the solution. So I very proud again. So he told us that now we should try to find producers to mass product all these components which are needed in the passive house, like the insulation, like the windows, like the glazing system, like the ventilation system. So all these parts which are needed to make a passive house work, that shouldn't be just produced individually for each building, but it should be produced by in a big marketplace by different producers, and then the cost will come down, and so with a reduced cost, it could be used everywhere. So this was the idea of Amory. And, well, we started that. So again, we were able to convince the regional government, that's the Hesse government, and they financed a small working group of a few architects and a few producers in order to go on with the development of the so-called cost-efficient passive house. Well, and now I make a big jump. A big jump. We are now in 2013, last year, and show you some examples of built passive houses. This is what came out of the development. So now there are at least 50 passive house schools which have been built. A lot of social housing built in passive house, because social housing have to be not expensive. It's for the poor people. This is a passive house kindergarten. This is a passive house swimming hall. And this, very interesting, this is a passive house office building in the center of Vienna. It's an office building of a big financial institute called Raiffeisen. And the interesting thing of this passive house is that it's standing at the same place where had been the former OPEC building. OPEC is the oil-producing countries. Now we go away with the OPEC and we put on the passive house. So this is a sign of the development which is going on in Europe right now. So now you might be curious, if this is so successful, how does it work? And I want to show you how this concept is working using this example. This example, it's another friend of mine, Professor Enno Schneider. He is an architect in Kassel. And this building is the very first passive house social building, which has been built in Kassel in the year 2000. Built in 2000 in Kassel. It is part of it's part of a big European demonstration project. So the European Commission, which is the government of the whole continent of Europe, the European Commission has research programs, and they started a program which was called CFIUS. CFIUS, this is an acronym for Cost-Efficient Passive Houses as European Standards. And we have been working with the European Commission quite a lot. Now, when I tell you that the European Commission is somehow the government of Europe, you might be surprised, because who of all of you knows the European Commission? Yes, yeah, me, yeah, I know the European Commission. So how important is the European Commission? Well, it might be as important as the United Nations. How important is the United Nations? So the powerful people are still the national governments. Yeah? So the European Commission, it has some influence, but it's not the most powerful part in Europe. But the European Commission financed this study. So now let's look. This is a social housing project. So social houses has to be inexpensive because it's for the poor people. It's built by taxpayer money, and if you use taxpayer money, you have to be very inexpensive, because otherwise the taxpayers will be very angry. So this was not an expensive building. So let's look what did the architect do in order to make this a passive house. So, well, what we see first is insulation. So, well, and it's a very simple thing to understand. If you want to keep your coffee hot, what do? Well, you fill it into a thermos bottle. This is insulation. You can keep the coffee hot without using any energy by filling it into a thermos bottle. And this is the principle of a passive house. You see, there are thick layers of insulation in the roof, on the bottom, in the walls. Everywhere there's not a window, we have a very, very good insulation all around the building. So the building doesn't lose a lot of energy to the outside during winter time. Now, there might be some questions some people ask: when you have that thick insulation, what will happen in summer? Will it be even warmer during summer because the insulation somehow is warming your house? No, well, that's not true. You have to think about that like a physicist thinks. If you want to keep your iced tea cold, what do? Well, you fill the tea into a thermos bottle, because the thermal bottle is keeping the tea cold. There's no energy going into the bottle. So what is keeping you warm during winter is also keeping you cold during the summer. So the same material is useful for the summer and for the winter condition. Now, insulation is very important for the passive house, but it's not just insulation. We have also to be very careful that all parts will be insulated well. So there are parts of a building which we call thermal bridges. So the thermal bridges, these are points where the insulation might be weakened by concrete or by steel or by other materials which is going through the insulation. So we have to reduce these thermal bridges. This is also part of the passive house concept. The third part is the passive house windows. Now, what is a passive house window? No, what is a passive house window is a little bit dependent on in which climate we are in. So in the German climate, which is very similar to North Japanese climate, the optimal window is a triple pane window. A triple pane window with two low E coatings, which is only losing a very small amount of energy. So we have almost no energy losses. But we still have energy gains from the solar radiation. So this triple pane window is the best solution for, say, moderate cold climates. If we go to even colder climates like northern China or like Siberia in Russia, we need even better windows, and the best available windows nowadays are vacuum insulation windows, which is the technology of the vacuum flask being used for the window. But in Japan, it's a triple pane window in northern Japan. Well, if we go to the south of Japan, where it's very hot and where you mainly want to protect from too much energy during the summer, a sun protection glazing is the best solution. So it's different. What kind of glazing you are using is different depending on the climate you are in. So that is the passive house window. Now, of course, the building envelope, it's not only insulated, it also has to be airtight. Well, why? Well, you might have seen, and this is very easy to realize, especially in hot and humid climates, so you will be aware of that. During summer, you very often, in old houses, you very often have a problem of mold grow inside of a building structure because humid air is infiltrating through the structure and there might be condensation in the structure, and this gives mold grow and structural damage to the building. So this is why a building envelope has to be airtight in order to avoid structural damage. And there is a fifth point, that is, of course, people in a building, they need fresh air. So it's not an option just to seal up the building to make it airtight. We need fresh air in the building. So fresh air is provided by a ventilation with heat recovery, MHR. This is the American pronunciation for the heat recovery system. So there is fresh air delivered to the building and exhaust air is removed out of the building. Mechanical ventilation with heat recovery. So these are the 5 elements of a passive house, and these are the same elements everywhere. These are the same principles you can use in order to build passive houses, which are very successful. And the surprising thing might be that these are the 5 points. So there's nothing else. So this sounds too easy to be true. Yeah? It's just 5 elements, well known: insulation, better windows, airtightness, reduction of thermal bridging, and ventilation with heat recovery. It's just a very simple principle. And this is the surprising thing. This really, really works. So now there's a lot of discussion about cost. And I have heard it's also a discussion in Japan, and we discussed it before the symposium, that there are lots of people who think that has a too high upfront cost. Now, let's be honest about these developments with the cost. What I have here, that is the amount of energy which is needed for just heating the building. Let's just at the moment, for the moment, look at heating. So you can have 100 kilowatt hours per square meter and year, or you can build a zero energy building which doesn't need any heating at all. That will be say 1 meter of insulation. Now it's clear that in order to reduce the amount of energy you need, you will have to improve the insulation. So this is maybe 5 centimeters of insulation, where we have 10 centimeters, where we have 30 centimeters, where we have 1 meter of insulation. So the overall cost for insulating is increasing. Now, this is not only the cost for insulation, it's also the cost for the windows, the cost for the ventilation system, everything included. So the costs are very much increasing. So what you see here is that a zero energy building, a building which doesn't consume any energy, this might not be a good idea because it's really very, very expensive. But on the other side, building just a not very well insulated building, well, you have a downside of that, and that is the heating cost. Here we have the heating cost. So of course the heating costs are coming down. Yeah, so we have the highest heating cost with a less insulated building, and you have, of course, zero heating cost with a zero heating energy building. Now, this is the total amount of heating cost over the whole useful period of the building, and this is calculated in the way a bank manager would do. So it's calculated by calculating the so-called net present value. So there might be people here in this room who don't know what a net present value is. It doesn't matter. Just think about it, that it is the total amount of cost you have for paying for the energy. It's what the financial sector uses for comparing costs which occur at different times. So the costs which occur in the future, in the faraway future, you don't care so much about the cost which you will have in 20 years. So these costs are not as valuable nowadays. They don't have such a high net present value than what you spend now. So this is added up in exactly that way how the financial sector does it. So this is the green curve, net present value of the energy cost. Now, there are no other costs. There are costs for, say, maintenance. Yes, of course, but the maintenance costs are about the same in both cases, whether you insulate or you not insulate. Even the maintenance cost might be lower in a good insulated house, but we won't take that into account now. Now, these are all the costs, so we can add them up. We add the investment cost and the energy cost, and what you find is the red curve. So the red curve, this is the total cost. So this is what somebody who is a resident in this building will have to pay. That is the total cost of occupation in that building. And what you see now is that there is a minimum. And this minimum, this is exactly the minimum of a passive house. So the passive house is at the minimum of a total cost for the overall spend in such a building. And this is quite easy to understand also for all those who are going to build new buildings. This is the best way to do the investment you take. You'll have a loan, you will pay interest for that loan, and you can compare the paid interest and the payback with the energy you are saving. So this is why the passive house is a very attractive solution, because it's the least cost solution for building a new construction in Germany nowadays. I'm coming back to the 5 points. What are the important design methods for building a passive house? I come back to what Amory Lovins convinced us to do. So nowadays, we have a lot of different producers who offer passive house construction systems in Europe. So this is a type of just a simple brick, insulated brick structure, which is distributed by the brick industry. So the brick industry have passive house bricks. This is a method you can use concrete structure in order to build passive houses. It's a so-called insulated concrete form, ICF in America, very popular. So you build, this is like Lego, so you build your building like with Lego stones, and it will be filled with concrete, and these are the forms, and the forms will be kept in place, so they are not removed, they don't have to be removed from the site, don't have to be destroyed, so this is also environmentally quite an interesting development. There are lots of others producers who produce these passive house elements. This is another construction type which is much more popular in Japan. That is a timber construction. So there are different ways of timber construction filled with insulation material. So one type of insulation material you can use in passive houses is the glass wool insulation or mineral wool insulation. And there is some probe you can see in the exhibition outside, which is produced by Isover, by the firm of MIG, which has been helpful in organizing this event also. You can also, of course, use other types of insulation. There are lots of different types of insulation available. What we have to keep in mind is that insulation mainly, normal insulation material mainly is just air. It's just air, what is insulating, like our clothes. It's just air. It's not depending on what kind of material you use to keep the air from moving. If the air is moving, it's not insulating, it's convection. So then this is a bad idea. So the air has to be kept at the place, and this is where the insulation material comes in. So this is what the solutions which have been created for the structure of a building. Now, there are already more than 100 producers in Germany. This is again what the speaker before me told you. This is a big development of small and medium enterprises. So the small and medium enterprises, they are providing these materials which are saving energy. So this is a big shift from the big industry, oil, gas, and coal, and nuclear, to small and medium enterprises who construct the energy-efficient buildings. So what is our role in this? Now we help these producers to design their solutions. So this is a type of a timber frame construction widely used in Germany. Now this has to be connected to the insulation of the basement. So what you see here is a specific structure, how to make that join, how to make that join in a way that there is no extra thermal bridge. So the thermal bridge is eliminated from the whole envelope, and this is possible. And this can be done just by using your brain. So we are substituting energy losses by using our brain in order to construct better construction. So this is the construction which is widely being used. Let's go to step 3. You remember, I have shown you 5 points for construction of passive houses. Now we have seen insulation, reduction of thermal bridges. I'm going to show you what is the solution for the windows. So now we are in a cold climate. You see in the outside, it's a winter condition, so there's snow outside. It's minus 15 degrees on the outside. And we are in the inside. In the inside, it's 22 degrees. That sounds comfortable. But now let's look on the window. This is a standard single-pane window. So a standard single-pane window will have frost on the inside with minus 15 degrees outside. So it's not comfortable at all. If you put your hand on that, you will freeze on the window. A not very comfortable solution. The next step was to just add another pane. So we are at a double pane window, which is better. So now the temperature on the inner side is higher, it's above frost, but you still have condensation on this side, and 14 degrees is still not very comfortable. So the next step was that physicists brought in what is called a low emissivity coating. So the low emissivity coating, this is a very inexpensive process in industry to coat the window with a small metal layer which is reflecting the infrared light. So this is like in the thermos bottle, the reflection of the infrared. So this gives a very much better window. So now we have a window with a surface temperature in the range of 18 degrees. This is much better. This was the type of glazing which has been mainly used in new construction in Germany up to a date in the last 5 years. So up to 2009, 2010, this type of double low E window was the mainly used window in Germany. And what happened then? Now 70% of all glazings which are used in Germany, new construction and refurbishment, 70% now are already triple glazing. Triple glazing, you just add another pane with also a low E layer. And now we are down to a very low heat loss, and we are up to a very comfortable surface temperature. Now, if you put your hand on the surface, it's 20 degrees. It's as warm as your desk is. So this is not cold anymore. So this is a very comfortable situation. And the prices of the triple glazing have come down in Germany very much. So nowadays, it doesn't matter. It's even in some parts nowadays, because this is the mainly produced window now. Nowadays, in some parts, if you want to get a double pane, it will be more expensive than the triple pane, because the triple pane is the standardized mass product solution. So Amory Lovins has been exactly right. If you go to produce these elements as the normal solution, it's not going to be expensive. And this is what happened. Now, it's not just the glazing. The glazing is something which is produced by centralized industrial fabrication. It's also the company of Saint-Gobain, for example, which produces glazings. But there are some others like Pilkington and Shot Glass. So there are lots of those producers of glazings, but it's produced in a centralized factory. What is locally produced is the frames. So this is a typical German wooden frame which has been used most of the time. So if you have this old window with a normal frame and a double glazed pane, it is a heat loss window. It's still a heat loss window. So we have a lot of energy losses from the window. Now, what we did in the development of the passive house sector, we moved the frame around. So now it's positioned in that way, so it's much slimmer than the old one was. And we added some insulation on the outside of the frame. So now this is a very well insulated frame. And this is a triple pane glazing with a thermally insulating spacer. So at the end, what we get at the end is a window where it's not longer a heat loss window, it's a heat gain window. So we get more solar energy into the room by penetrating through a window from the outside with solar radiation, so that the room gets heated during winter by the solar energy, and the heat losses are smaller than the heat gains. So this is what took place in the passive house revolution, part of the energy revolution in Germany. So this is going to be the window of the future, and hopefully when I'll be here next in Japan, that's a condition. I'll come back to Japan only if there is a Japanese-produced passive house window. We'll need a passive house window, from Japanese production. So there's another advantage to these better insulating windows. So the window has a cold surface. So at the cold surface of the window, the air is cooled. So now the cool air is falling down along the window, and it will distribute on the floor. So you get cold feet. You might know that from your home, that there is cold air coming down. Now, if we have a passive house window, the temperature here isn't very low, so you won't get any cold feet any longer. So the comfort in a passive house is much better than you are used to the comfort in standard buildings. It's another advantage. So now I'm coming to point number 5. I won't talk a lot about airtightness because I already told you what is important, why we need a building envelope to be airtight. It's mainly to avoid structural damage. I'm not going very deep into that. But next step, that is what always has been a discussion everywhere. Why do we need ventilation? Why do we need ventilation? I won't talk about that. This is why you need ventilation. We have a lot of emissions in a dwelling, and it's also us. You know, we are also giving smells and humidity, and there's a lot of activity going on in a room where people are staying. And this is the reason why we need ventilation. So ventilation is clear, it's for indoor air quality. This is the main issue of ventilation. Ventilation is about indoor air quality. And I say it again, ventilation is about indoor air quality. It's not about energy. Yes, we can also improve ventilation in order to save energy, but that's not the important thing. The important thing is ventilation is for indoor air quality. This is why we need ventilation. And this is how it's done. We have fresh air. This is air coming from the outside. And the fresh air is distributed into each dwelling. So now let's look at that dwelling. This is fresh air which is ventilated into the room. Oh, we have the same thing here, of course. In this room where we are sitting, in this hall, this conference hall, there are fresh air supply outlets because we need fresh air inside here. So this is distributed to the living room, to the bedrooms, to the working rooms, so everywhere where the people are staying. And then there is the stall air, the air which is coming from the kitchen, from the bathroom, from the toilets, maybe a workshop or whatever. We remove the air, we extract the air from these rooms where we have the poorest indoor air quality and bring it back outside. This is how ventilation works. Fresh air in, stall air out. Now the only trick with the passive house ventilation is that we put in something which we call a heat recovery system. A heat recovery system. Now, how is that working? Well, this is what you see here. This is the extract air, the warm air coming from the kitchen, from the bathroom, from the toilet. We bring it through the heat exchanger, and it's removed outside of the room. Now think about a piece of paper here in between the cold, fresh air which is coming in from the outside and is supplied to the inside. These airflows are not mixed up. It's no return air. It's only fresh air from the outside. But we exchange the heat from the warm air to the cold side. And with modern heat exchangers, we can have efficiencies of this heat exchange of up to 90%. So we can bring back 90% of the heat from the stall air to the fresh air. This is such a type of heat recovery ventilation system. Now, there is a lot. Remember what I said. Ventilation is about indoor air quality. So there are a lot of issues with such a system which they have to fit for. They have to provide good indoor quality, so they shouldn't smell. So there have to be filters that you don't bring dirt into the room. These ventilators don't have to produce a lot of noise. It has to be quiet because you don't want to hear all the time something. So there are a lot of criteria for this system. This is another thing where our institute is engaged. So we are doing certification for these kinds of systems. So you can get a certificate, and in this certificate you find all the numbers. You find how high is the efficiency of the system. If you install it in your building, it's the installed efficiency. This type, it's 75%. How high is the consumption of electricity for the ventilators? What is the operating noise? Yeah, so you get all these numbers, and you can be sure that the product will meet these numbers. So you can really use it in your dwelling in order to save energy and in order to have good indoor air quality. So I'm now wrapping up. That is, I have been talking about better insulated wall and roof systems. So there are a lot of these systems now available on the European market. And yes, we need more of these systems, and especially also in Japan, we'll need a lot of these construction systems. The better windows. Nowadays we have 150, this is an old slide. Nowadays we have more than 150 certified window producers, most of them small and medium-sized producers. These small and medium-sized producers can compete with the big plastic window producers in Germany because they have such a high quality. So this is a big chance for small and medium enterprises. So this is not only good for energy, it's not only good for changing the energy path, what IEA says, it's also good for economy, because the small and medium enterprises, those are the people who are carrying the economy. Those are the people who are innovative. So those are the people who can help us to grow the economy. There are a lot of window panes which are available on the European market. Well, I'm very proud I can announce that now there is a first Chinese-made passive house window. There's a certification for a Chinese-made passive house window. And hopefully there soon will be also Japanese-made passive house windows available for the Japanese market. We have these heat recovery systems. Nowadays it's also more than 100 systems which have been certified. This is also a product which can be easily produced by small and medium enterprises. They use efficient motors which are constructed by mass production of bigger industry partners which are producing with very efficient ventilator units. I'm now going to show you in the end of my presentation, it's a little bit less demanding. I'll just want to show you some examples so that you keep in mind what we can do with that type of technology. This example you have already seen on the first slide, but this is now a big picture of this. These are some 350 social housing units which have been built by a company in Innsbruck. It's the biggest construction company and investor company in Innsbruck, building houses, social housing. They had built that in 2004. Some of you have been visiting this settlement already. Now you have to know that this company, after they built these passive houses in Innsbruck in 2005, they decided that in future they'll only build passive houses. So this company is going to only build passive houses in the future, reducing the energy demand by 80%. So that's another example, and yes, it's easy to see this is not a passive house. This is an old postal building. It's near to the station in Bolzano. Bolzano is the capital of the South Tyrolean state. It's a state in Italy. And so we wanted to refurbish this building. And they made a competition where they invited a combination of a constructor and a architect in order to bid for the refurbishment of that building. It should be refurbished and there should be 2 more floors added. And the investor is the Ministry of Energy of South Tyrolean state. And they gave the contract to one bidder, and that was organized by architect Michael Tribus. So Michael Tribus organized the cheapest bid. He didn't tell them that he was going to build a passive house, because if they would have known that this is going to be a passive house, they would have told him, "Oh, well, okay, let's not do that. Let's remove the extra insulation and so on. It will be even cheaper." No? But he didn't tell them. So he made the cheapest bid, including the passive house. And now it looks like this. So this is what has been constructed. This is the first passive house ministry worldwide. Now the ministry is residing, the energy ministry is residing in a passive house. It was the first refurbishment of an office building into passive house construction. Now this building is heated by a 20 kilowatt natural gas stove, and the heating the heating handicraft who installed this system, he very proudly, he put it on his internet page. He said that that kind of heating plant we have been using in single-family homes before, and now we are heating the whole ministry with just that very small unit. Now the South Tyrolean energy minister, now they are very proud that they have a passive house. Yeah? So that is interesting also. Yeah? Now they are very proud that they have that passive house, which is very comfortable, which uses a very small amount of energy. Now, how can we do all these development? And well, there is a key method for designing passive houses. That is, if you design a passive house, you try to keep the energy balance in the mind. Now, this is something what physicists do and engineers do, but most likely architects don't like very much. They don't like to calculate their energy balance during the design of their houses. So that is why we created a tool which is called the PHPP. Now, what is that? PHPP. It's the Passive House Design or Planning Package. That is a package of software where you do the following. Who is an architect here? I'll be such. Oh, there are more architects there. You know SketchUp? Yes, yeah. Every architect knows SketchUp. So you do your first draft using SketchUp. It's very fast, sir. It's very fast. You just have a drawing and put it up, and you do your first draft using SketchUp. I also tried it myself. I'm not an architect. I'm a physicist, so I'm not used to use such types of tools. But interestingly, this is fun. This is really fun to build up your building with SketchUp. It's very fast. You just 5 minutes and you are at that place. It's 5 minutes, 5 or 10 minutes. And now there is a software which identifies your windows, it identifies the walls, the roof, and so on. And it's very accurate in identifying it. Well, there may be some mistakes, maybe that he calls a part of that outside structure also a roof. You have to remove that then, have to call it, it's not a roof, it's something else. But it takes only 2 minutes to correct this identification. And now you just have one click more, and you will import all these data into the energy balance calculation. The energy balance is calculated, you get your result. This is your heating demand. Oh, that's too high, much too high. So now you can go on and can change the amount of insulation. You can change the window. You can change the size of the window. You can rotate the building and calculate it again. And in this way, you can calculate for your house, and at the end, it will be a passive house. So this is a tool architects can use in order to improve their building designs. You remember I've been talking about a famous European project which was called Cepheus. If you ask the European Commission, they'll tell you that that was at least one of the most important projects which was ever financed by the European Union. And now we have another one that is called PASREC. PASREC, this is Passive House Regions. And these are beacon projects, and they are including some cities you know, the city of Frankfurt, the city of Brussels, the city of Heidelberg. Now, what is common of these cities? Well, one thing which is common, it is when you are traveling to Europe, you will visit these cities. You are in Heidelberg, you go to Frankfurt because it's the big airport, and you will be in Brussels because it's the European capital. But there is something else which is common of these cities. They already have passive house mandatory. So if you build a new building in Frankfurt, it has to be a passive house. And if you build a new building in Brussels from 2016 onwards, it will have to be a passive house. So this is already a beacon for what will happen in the whole European Union, beginning from 2019. The European Commission proclaimed that from 2019, in all European states, in all European regions, only nearly zero energy buildings are allowed to be built. And that's an acronym for passive house. So beginning in 2019, in Europe, only passive houses will be built. Hopefully. I already told you that the power in Europe is not with the European Commission. The power in Europe is still with the national governments. So the national governments have, of course, to decide on their own what they are going to do. And, well, I don't know exactly what the national governments will be deciding, because the national governments are always under a lot of pressure from lobby groups. There's a lot of lobbying going on at that time. So this is what you hear sometimes from Germany. If you hear from Germany, oh, people are complaining about high electricity prices. It's not true. This is just misinformation coming from some vested interest groups. Yeah? So the people like that type of development because they are spending less money than they have been spending before. So this is why the European Commission started the beacon regions, the path-track regions, because now the European Commission is demonstrating that this is working. So the regions of Brussels, of Frankfurt, of Heidelberg, they will be successful, so they will have higher living standard than all the other regions. So the European Commission can tell, look, this is working, so this is a good idea to go for the better efficiency. This is a European project. Now, there are, of course, much more details to energy efficiency than just housing. So energy for housing is quite high. It's the highest consumption we have. The heating and the air conditioning systems, they have the highest consumption of all other things. But of course, also computers are consuming electricity. So this is an old display with a quite high consumption of energy. So now that's the latest development we have, which is called electronic ink. Electronic ink doesn't consume any energy for the display. Well, it's the same with your papers. Just want to show what is the energy consumption of that piece of paper displaying the picture on it. There's no energy consumption. And that is the same we have with electronic ink. So the electronic ink stream doesn't consume energy. So if you have such an electronic ink reader, you can place it on your desk, and after 2 weeks it's still running and it's not consuming any energy. So this is the modern way of reducing the energy demand of our systems, and that will work with everything. Another example, this mobile phone, this smartphone, it has a computer inside, and the computer inside of this phone has much higher capacity than the computers me and Professor Bo Adamson and Professor Kamata used in order to calculate the first passive houses. So we can do all those calculations just with that smartphone, which just consumes 1 watt. So this is the real innovation, the innovative things going on, having highly energy efficient components. Now, some people say that this is electronic ink is just black and white. No, it's not true. There are also color electronic ink systems. So that will be the upcoming next generation of displays using electronic ink without any energy consumption anymore. What about the spread of passive houses? Well, some people ask, why is that being used in Germany only, and why isn't it also used in the US, which was to be the most innovative country worldwide? Yes, it's true. The United States of America, they had a very good development in the late 70s and in the 80s towards sustainable energy. There was an American president called Jimmy Carter, He very much engaged in sustainable energy development. And they built so-called super-insulated buildings. They just made one mistake. And I urge you not to do the same mistake. They were only dependent on governmental money. So in order to do that research, they needed governmental money. And now the government changed. It changed from, you remember who it was? It changed from Jimmy Carter to Ronald Reagan. And he stopped the whole program. So all these people out of jobs, out of profession, so that stopped the whole development in the United States of America. Some of these people were coming to Europe, like Robert Hastings, and working together with the European part. And that's one of the reasons. In America, there was no incentive for doing that development, but in Europe there still was. So that is one of the reasons why it started in Europe. There are several other reasons also. But after it has been successful in Europe, it's going back to the US. So nowadays, we have a lot of passive house communities in the US, in Canada, in Mexico, even in Southern America. There are worldwide passive houses being built, also in People's Republic of China. Of course, in Japan, Mifamori will talk about the Japanese experiences. In all continents, we have passive houses being built. In Australia, and even in Antarctica. There is a Belgish research center built as a passive house in Antarctica. So we have the passive house already worldwide. It's everywhere. It can be adapted to every climate, also the hot and humid climates. The Austrian embassy in Jakarta is a passive house. So it's already been realized. It's a good solution. It can be used in all parts of the world. So now, of course, if we want to build passive houses in other parts of the world, we have to look how to do that. It's clear that a passive house in Himalaya will look different from a passive house in Jakarta. That's completely clear. It's the same principle, but the house in Himalaya will need much more insulation. It has to be insulation of 40 centimeters, like that. The house in Jakarta, it will be enough to have 10 centimeters, 12 centimeters of insulation. So this world map is showing you the world in a little bit a different manner. This world map is showing you how much insulation do you need in order to build a passive house. So you need a lot of insulation in Sweden, in Norway, in Himalaya, northern part of Japan. And you need almost no insulation in the highlands of Mexico, some parts of Africa. Yeah? So these are what we call the lucky climates. In these lucky climates, almost all buildings are passive houses anyhow, because you don't have to heat and you don't have to cool. Now, if it comes to some desert climates like Sahara or the Arabic Desert, we need more insulation again, because we have to insulate for the heat coming in. So this was a result of a study which has been financed by the German Foundation for the Environment. There's a German Foundation for the Environment, and they financed this study, which is published. You can look for this study on the internet. I will show you later where you can find it. So this is giving you some ideas what amount of insulation, for example, will be needed in this northern part of Japan, and now we are more to the Tokyo region, and when you come to the southern part of Japan, there will be less insulation needed. We also looked for what is the appropriate window. So in the cold regions, I already told you, it may be a vacuum window. So the vacuum window is what is needed in northern Finland, northern parts of Norway. Well, not a lot of people living in these areas. That's only a few people, a few 100,000 people living in these very cold areas. Now there is a cold area which is northern part of Japan, northern part of China, middle part of Sweden and Norway, the northern part of the Midwest in the United States, and most countries in Canada, most states in Canada. In this part, we need very well insulated triple pane, low E windows. Even in some places, we might need quadruple pane windows. And then there is the moderate cold climates, most parts of northern Japan, Germany, England. These are the crowded populations we have. And there is a moderate warm climate, that's the rest of Japan, southern Europe, parts of Asia, a lot of parts of America. And then there are the hot climates, you see here, and the lucky climates, the yellow ones, where it doesn't depend very much on the window. You can choose whatever you want, but you might need some shading, of course. The wet climates, these are shown in these parallel lines. So these are the climates where we also have to look for dehumidification. So that's also part of this international study we have done. Now, in order to spread the knowledge about the Passive House, there is an international Passive House association. So the International Passive House Association is giving information, is communicating about passive houses, is developing passive house educational material, is organizing meetings, and so on. So we really invite you to be part of that international development. Japan would be a very good partner in this overall development and in this international network to spread the Passive House knowledge. One thing the International Passive House Association does is it creates Passipedia. In the Passipedia, you find information for the public, just information like I gave you here, but of course you have seen each of the slides I have had. I could have talked another hour on each of the slides, on the details of the glazing, on the details of the frame, on the ventilation system, and so on. So there are informations you can just get from passipedia.org. Passipedia.org, you find these information freely available for everybody. And then there is a part two, that is a part for the architects, the engineers, the producers of material, which gives detailed information of how to solve specific problems, which is not in public interest, but which is needed by the architects. So this is for the members of the International Passive House Association. We are also organizing educational courses. That was started in 2008. Now, most of you might think, why education? So at the moment, your main task is to spread the knowledge, to just tell people that they can use passive houses. But I can tell you, this was the experience we have had in Germany, it will grow very fast. So there will be, in the next 1-2 upcoming years, you will lack of those people who are skilled to do that job. So you need more people who are skilled in that job. So you need to have education. The education should be, of course, at the universities also. We have a lot of university partners who are providing this education so that the newly educated architects already know about that. But there also has to be, of course, professional education, which is for those architects and those engineers who are already in their job. And this is what we do with the International Association. So there is a growing number of educated passive house designers, passive house consultants all around the world. This is taking place everywhere in the United States, in Mexico, in Canada, in Korea, and also in Japan. Mivamori will talk about that later. So this is my last slide, and yeah, that is what professors seem to do. They talk a long time, so that's now my last slide. So you can have your coffee then after that slide. I'm just telling you one of the other activities, what we are doing upcoming next week. End of next week, there is the International Passive House Conference. It's already the 18th International Passive House Conference. This time, it takes place in Aachen. Aachen was some 1,050 years ago, that's a long time, 1,050 years ago, it was the capital of Europe. It was in the time of Charlemagne. Charlemagne, the big emperor who was all over Europe. And the Aachen people, they are still proud that they have been the former capital of Europe. The International Passive House Conference will take place here. We normally have some 1,000 participants coming from all around the world. We have simultaneous translations to a lot of languages, including, of course, English, but this time also French, also Chinese, and for the first time, this time, there is a Japanese simultaneous translation in the Passive House Conference, because there are a lot of Japanese people coming to the conference, and this will be a possibility to spread the knowledge about Passive House from the experience of all the speakers which come from all around the world. Thank you so much for being so patient for my presentation. Thank you.
ファイスト博士、どうもありがとうございました。Thank you very much, Dr. Feist。改めて大きな拍手をお願いいたします。